Hello. Hello, ladies and gentlemen. I'd like to call your attention to the start of the session. So, good morning, ladies and gentlemen. It's my pleasure to welcome you all to this session this morning, where we're looking at the question, Fourth Industrial Revolution technologies are transforming manufacturing across geographies and industries. How can innovative approaches leverage these new opportunities for the production workforce? And with me today on the panel, I have to my immediate left, Mr. Danny Yuan. He's the Chief Executive Officer and President of the Greater China ManpowerGroup here in China, which, as he tells me, is a joint venture in this country. I also have just next to him Professor Yin Chan. She's an honorary professor of Technology-Enabled Learning Initiative in the University of Hong Kong. Next to her is Mr. Carl Vause. Is that the correct pronunciation? Yes? And so he's the CEO of a company called Soft Robotics, and you'll be hearing more about what that does. And last, at the end, but not least, we have Natan, Natan Linder. He's the CEO of Tulip Interfaces and also the chairman of the very innovative 3D printing company called Formlabs. So my name is Kamau, Gachigi, and I'm from a company in Kenya called Gearbox. It's a platform for the promotion of technologies, and so it's an interface for bringing in Fourth Industrial Revolution type technologies into a setting like Kenya. I also work as the chairman of the board of an organization called the National Industrial Training Authority, whose job it is to make sure that training in the workplace in Kenya is done effectively and in response to the needs of industry. And as well as that, I chair, I'm on the board of an organization, it's a state corporation for manufacturing called the Numerical Machining Complex in Kenya. Before I get to the rest of the panelists, I just want to say a little bit about the work that we're doing in Kenya. With the National Industrial Training Authority, as I said, our purpose is to meet the needs of industry in a part of the world where there's 90% of the population is in the workforce rather is in the informal sector, and only about 10% is in the formal sector. This is quite typical of a lot of African countries. And so the challenge is how to get the right skills into a sector that's informal and in effect it's invisible to the government. There's no taxation. The numbers and statistics around exactly who's doing what are quite limited. So the challenge is really quite great. And what we've been able to do is to look around the world to benchmark to see how best, which are the countries that really do this very well. Countries that come to mind are Germany and South Korea, but we decided to look at Brazil and India because they're much closer to us in terms of their histories. And in both cases, we found that they've given over the role of training to the private sector. And so we, as the National Industrial Training Authority in Kenya, we own a lot of different training centers, and it's our role to actually train. But government very often doesn't run things as well as it should, perhaps. And so we're in the process right now of transforming the way that we do this. So we retreat into the role of an authority. An authority is supposed to regulate the training and let the private sector actually do the training. And we're really leaning heavily, as I say, on the models from Brazil and India. And especially India, because India is also historically a colony of the United Kingdom. And that means that a lot of the systems that they have are very similar to ours. And they've also gone through a similar transformation quite recently. And we're receiving quite a lot of support right now from the World Economic Forum. I sit on one of the councils, that is the Council on the Future of Production, the Global Council on the Future of Production. And because of this interface, I've been able to receive a good deal of assistance from the World Economic Forum in terms of connecting and learning from others how best this can be done. Having said that, we're also looking through Gearbox, which is my day-to-day job. We are actually out of what's called the Fab Lab network. Just by a show of hands, how many of you might have heard of the Fab Lab network out of MIT's Media Lab? And so we basically consider ourselves a super Fab Lab because we have more equipment than a typical Fab Lab, and also we kind of seed the creation of new Fab Labs. And one of the philosophies around Fab Labs, the main theme is how to make almost anything using digital fabrication. And the next theme up from that is how to make the machines that make almost anything. So we're currently in the process of making CNC or computer numerical controlled machines and then pushing them out into this informal sector in particular, training people on how to actually use the machines. And then in a partnership with a bank, a very large bank in Kenya, they pay for the training, and 20% of the people trained are business owners in the same informal sector. And so they already have revenues. And so we teach them how to use, for example, a plasma cutter to more quickly and precisely cut sheet and plate metal to be able to build stuff that has already got quite a good market, but now to do it a lot faster. And then it's upon them to hire at least 4 of the other trainees as apprentices. And then in the process of that apprenticeship, they learn and are able to actually, on one day of a week, use that machine for their own business and then get a loan themselves from the bank. So we're hoping that this experiment will yield fruit, and the fruit that we're looking for is in a very basic setting where people are cutting metal even with a chisel and hammer or with a grinder without much accuracy at all or repeatability. Introduce CNC machines and see what's going to happen. What are people going to make? As well as that, in the training, we're very heavy on human-centered design. So teaching people design thinking. And for this, we're partnering with people in the D-Lab, Development Lab at MIT. And they've been doing this around the world through summits. So they take 2 to 4 weeks to train people who might not even speak English at all. But they have a very flexible pedagogy and curriculum so that they can teach them how to use the tools they're already using, but use them better because of design thinking. So having said that, that's the background to what I do. It's my pleasure now to move on to the panelists. And the first question that I have, I'm going to direct to Natan. How are technologies, that is 3D printing, advanced robotics, artificial intelligence, Internet of Things, etc., changing the nature of tasks and jobs in manufacturing, especially on the shop floor? And obviously, you're going to deal with this question with regard to the kind of work that you do, that's mostly in the technologically developed world. But please, if you can just share your experience and thoughts.
Yeah. So good morning. It's great to be here. It's rather a wide set of buzzwords you just introduced all in one string. To be perfectly honest, that is hard to weave. And I think I want to kind of start from the human aspect first, because 50% of the battle, I mean, the technologies are here and now, and I think we can all agree to that. So clouds are here, and Internet of Things is here. So we can put, low-powered, IP-based, devices with CPU wherever we want and connected to machines. And big data, analytics, all those things you guys spend a lot of time looking at. Probably you can add machine learning, all that kind of stuff. It's all here, but 50% of the battle is like how organizations actually change and transform how they work, and that's really about people. And so I spend my time mostly now on 2 companies, both in a way are democratizing traditional means of manufacturing. So one is doing low-cost 3D printing platform called Formlabs, and we're shipping a small orange box that allows you to create pretty, professional-grade stereolithography on your desk. And a Tulip effectively is a manufacturing operating system. And so when you spend time on shop floor just watching what people do, you are really transformed 20 years ago, where people were in the last digital transformation when the PC was introduced. And fundamentally, you see paper and manual process. To change that, it's really about enabling people to make decisions based on data. And to do that, you kind of have to flip the IT stack, the traditional one, and let people create applications, much like we all run on our phones, but without writing code. And that's exactly what Tulip is focused on. And I think what we're seeing when you enable what we call innovation at the nodes, so when the process engineer or the safety engineer or the lean engineer start to change how they're working, you see cycles for new product introduction accelerate. You see build-to-order scenarios kind of manifest faster. And that, to me, is pretty exciting. And we're seeing it in small companies, which is the backbone of manufacturing. So if you guys are familiar in Europe, and United States, these are hundreds of thousands of organizations in the back end of the supply chain. And you're seeing it in larger organizations who provide mandates for innovation from the nodes within their very large manufacturing operations. And both of those coexist.
And I guess you coming from the Media Lab, and as I said earlier, I have some historical connection with Media Lab. Neil Gershenfeld, who started the Fab Lab network, often looks and says in the future he sees a time when personalized fabrication, digital fabrication, will become the norm, something a little bit akin to Star Trek. Do you see this, do you share that vision?
No. Because I'm a practitioner and not an academic, even though I do have a PhD. But the only place that would ever give me a PhD is the MIT Media Lab. If someone wants to read my very boring PhD, I'm happy to send it to you. But the reason I'm saying no so strongly is because unlike the pop academic mindset, there is no replicator. And this is wearing my Formlabs hat on. There's no machine that you go and say, like, make me this thing, and it would make the thing. It's actually, by and large, single process oriented additive manufacturing. So whether it's stereolithography or SLS, or we can name lots of different processes here, that then require not only post-processing, but integration or assembly or discrete manufacturing, in fact, to become the final product. And to tie it into Tulip and kind of explain how does that actually affect what I just mentioned, which is like we're moving to a world that is ever more customized, and Neil many times calls this a market of one. When Apple is building an iPad, there's roughly 300 pairs of hand that has to do stuff, and this is all after the mass production that happens, PCB layouts and all sorts of things like that. 90% of manufacturing it actually involve human labor, and humans are your most advanced computer on the shop floor. It has the best vision system. It has the best machine learning. You can program it just with a word, and I'm sure we'll hear about how we program robots here, and that's not going to change. And humanity is also not going to change. If you all refer to Max Frisch, who defined the human species as Homo faber, so this is like the technological mammal, and we're always going to make new things. So we need to find ways to create interfaces for people on production lines that allow them to be what they can be, to be that amazing computer, not just like an automated, do those little processes on the line. So if we do that, then we have this thing called the internet. You can imagine any product being customized end to end.
Okay, well, I wonder, Carl, this I'm going to direct to you. With regard to what Natan just said about the human being and the uniqueness of who we are, in light of what happened recently where Google's DeepMind beat a Chinese expert in the game Go, and we have robots that are able to do much better the repetitive tasks that are necessary on the shop floor. What is your view on that? How are these technologies changing? What's going to happen on the shop floor? What is happening now and what will be happening?
So I think this is a great setup, by the way. The most important thing that's happening on the shop floor right now is a lack of people. And that's very, very important. And so in the United States, as an example, is we have 6.4 million open jobs in the US and 5.8 million people looking for work. So there's 600,000 jobs in the United States right now that just are not getting done. There's a global trend right now where we have an aging demographic. And so just picking on the US again, because the US is kind of the last domino to fall here, is about 3 months ago, the fertility rate in the US dropped below replacement rate. So those 600,000 job openings are just going to become worse. So what's happening on the shop floor is we can't get people in to do the work. Now what's really interesting is now going to the Google example. That's a great example where a Go board, I believe, is 18 by 18 grid. And one of the experiments they did is they took the AlphaGo and they ran it on an 18 by 18 versus humans, and it won. And then they changed it to a 19 by 19. And what happened is the human Go masters adapted pretty quickly. The AI was unable to adapt. And so that's really where we are in the state today is you can train machines, you can train robots for very specific applications, but the agility and adaptability of the human being just is not there. And so the trend that we're seeing that I think is so important is let's find the dull, dirty, dangerous, repeatable task that no one's going to do, that we can't hire today to do because the people, the human beings can be more selective about the work they can do. So let's automate those, the repetitive, dull, dirty, dangerous tasks, but then let's use that very valuable human computer in quality assurance and management to make sure that these processes are running correctly. That's what we see today. Unfortunately, I don't think the technology is moving fast enough, and we don't have enough of those well-trained human folks to supervise this today.
Okay, thanks for that. So I want to move now to Professor Chan. And I want to ask, what are the different organizations doing to identify future skills needs in manufacturing and to keep pace with technological evolution?
Thank you. Great to be here. It's great to hear that both my fellow panelists affirm that humans are still important and it's basic to the process, because that's what I do. I'm not in hard production, but I've been a journalist and an educator, university professor for most of my life. And training is a huge challenge. And you talk about the thinking process, about managing skills on the shop floor. You need basic literacy. It means that the ability to communicate, ability to converse in languages is more important than ever. Those are basic. And thanks to technology, education at all levels are being disrupted. Give you examples of organizations. Like in China, where we have 800 million people online, which is only 57% of the penetration. It's still a lot way to go. And because of this very simple internet technology, there are organizations now engaging in the knowledge industry in the scales it's never seen before. You can have hundreds and thousands of students working on their own time, learning English with teachers from around the world, not in China, around the world. It could be in the United States, it could be in the UK, it could be in the Philippines, right? Huge industry. And then also, China is also offering courses in Chinese, right, to the world. One of the most popular MOOCs, massive online open courses in the world, is produced by the top university, Tsinghua, teaching Chinese. Why do you need to have someone in-house somewhere to teach? No, right? And that's happening. So we're training on a massive scale. Where I'm working at the University of Hong Kong, I'm consulting and attached to TELI, Technology Enriched Learning Initiative. One of the courses we just launched is on fintech. Now, Hong Kong is behind in fintech because we've been doing so well in real estate, in finance industry. We're slow in fintech, but now we're trying to catching up. So university is offering a very basic course in fintech. In 2 months, we have 20,000 users register online around the world, right, including in China. Now, China is very advanced in fintech, so they don't need to take fundamental courses from us. But what students are using, especially journalism, is using it as a language course to learn the vocabulary of fintech, because you have the text, right, alongside the speech. And then students said, well, you know, it's different accents. You know, it's hard to catch. Come on, this is a real world. There's not one English accent. There's all kinds of accents, so get used to it, right? And then we have a local bank who took out 1,000 licenses for their internal training. So that's happening. So I can see education, which is happening now, education is getting globalized, getting more personalized, getting more available. Not enough, not enough. I think education is very much behind the industry about what's happening because of credentials, because of obsession with turfs, and that has to change.
And do you see, therefore, disruption in sight where, for example, universities have always been looked at least for those who are expected to become leaders in industry and so on? Do you think that the MOOCs, for example, are going to start disrupting the way that people seek to get their education? Will they still want to go to the big institutions, or will they be able to just go online and not necessarily
that's changing too. MOOCs is per se. It has happened. It's proven. So now the issue is giving credentials to online courses. And already that is happening. Most universities are still resisting because universities has a monopoly until now on credentials. You need a degree. You need an MIT degree, right? But now even MIT, again, is taking the lead. I can do MicroMasters at MIT. I can do 3/4 of the courses online, right? Spend a semester there, I got a degree, right? And there are also 100% online courses being recognized. So I think the credential business is also breaking down, not fast enough, but it's happening.
And in terms of what you do with your organization, do you have any specific interventions for manufacturing?
For manufacturing, I am not sure. I don't. We're a bit slow on that. We're doing fintech. We're doing basic news literacy courses, media literacy courses, communication courses, and I think we'll get to that. One thing in Hong Kong is very interesting is that a lot of emphasis has gone into medicine, legal profession, finances. I think engineering now is becoming more, quote, sexy.
Okay.
And that's a good sign. And then I think we'll get to it.
Very good. And Danny, the same question to you, please. What do you think that, who are the organizations that are trying to identify the future skills required for manufacturing?
Yeah, that's a good question, actually. I think I'm the employment agencies, actually, around the world. We are one of the largest HR provider. And also we in the China area for 20 years. And the most important thing is we don't want the people lose job. We want everyone keep the jobs. So no matter the robotic will be the future or not, we believe one thing is the robotic just take the task, not jobs. That's the reason I think the creative, the more jobs and upskills is more important. But unfortunately, not all the organizations really are investing in this trend. That's the reason we think about more is two sectors. One is actually is the new model, which is public-private and the employment agencies. We have to working together. Another one is actually is a lifelong learning. So which in the ManpowerGroup, we have the research, which we call is skill revolution, which is a future skill sets, which is the three components. Number one, most important thing is human skill, just we're talking about. Number two is actually technical skill, which we still need to continue learning. The number three is a digital skill, which is a future. So now we're talking about this in-demand skill sets is a future for organization and for individual really to understand what they can benefit from that one. And we put a lot of effort to working with local government, society, especially in the first two, especially the human skills we call is learnability. And recently we just launched a new idea of the AirQ, which can help the people learning from the very beginning. You know, in China have 8 million graduates every year from the university. And also we have now the public announced like a 4% unemployment ratio. But the more will be after the, the more automatic and the new machines will be created for these low-skilled workers. So how to make them to upskill also need the learnability. And also we call in the career in-demand skills, which the people has to continue upskill. So that's the reason the learnability for the skill is very important. And the company has to invest for their career, for the individual, for the long-term learning. and to keep them in the jobs. I think that is we call the model of the public society and the employment agency working together and help the individuals.
And what's your experience where, especially with the digital skills, where there's a certain amount of education you need to have, really, even like looking at the base, the lowest educated cadre within the employment. What's your experience in terms of their being able to catch up? You know, it's one thing to say that they can be taught digital skills, but without the background, it might be quite difficult. Are there ways in which this can be made easier?
I could give you a good example. Actually, since last year, we partnered with several largest organizations in China, like a CPDA, CDA, working, which most of the focus is big data. And the big data looks like it's very complex and a big one, but actually it's a very low one. Everyone can use big data. So for the low end big data analysis, just like a clockwork, how to make your finding more efficiency, and also even like a finance, junior finance analysis, which can make your Excel more efficiency and the data to getting from a very small company, like just like 100, sorry, not 100, just less than 50 people's organization. So big data can be lower. And even in a factory, China, because automatic factory is a level, not like US or other part, they are in the progress of the automatic factory. But in this progress, they need a lot of even no university certificates people to get the big data numbers and their backgrounds. So you have to train the people only have like a little bit better than middle school capability. So this kind of training should be practical and make the program very exactly to their day-to-day jobs. That's the reason I think that we work with some of the Tier 1, Tier 2 cities in China, this kind of program to help them for the low-skilled workers to get the data-related skills. I think they need a step-by-step improvement, not so high-end technology. Yeah.
I guess this moves me to Carl. From the point of view of these challenges, who do you think is best placed to sort of solve the problem? I mean, private sector is where it's at in terms of manufacturing and so on. That's who's responsible for that. But there is surely a role for the public sector, academia as well. And could you sort of maybe talk about who the stakeholders are, how best they can work together to transform what's going on so that we're not always playing catch up with technology?
I think Danny brought up a very good point, which is it's not, we need everyone to have a PhD in mechanical engineering or electrical engineering, because a lot of the jobs that we're going to need in the future, you can have a high school education, but you have to have the right skills. And so I used the example of, does anyone here know what a PLC is? A programmable logic controller? So it's what, 1960s, 1970s technology? And it's still a key building block of robotics. The problem is they're not teaching PLCs in universities today. And so there's a lot of industries where they're trying to deploy PLCs, they're trying to deploy robotic automation, and the skills don't exist. And so the mechanical engineers, the electrical engineers don't know how to program it. They have a very expensive, very valuable degree. But at the same time, we're not teaching these skills at the apprentice level, high school level. And so where I look at it is today, the private sector is filling that gap. And so the private sector is working with an edX. There's a PLC course on edX to develop that. They're working with the community colleges. The example I'll use is in Detroit. There's a Oakland County Community College. It's a 2-year community college. And the auto companies couldn't hire anyone to program their robots. And so they actually went to Oakland Community College. They developed a 2-year degree, a 2-year associate's degree in industrial automation, how to program robots, how to set up a PLC, safety, things that are so important. And I think that program's been running for 6 or 7 years now. It has 100% employment. So those students that come out of high school, they go to 2 years of associates at a community college. They graduate, all of them are employed. I think they're starting about 80,000 US a year with full benefits. And so there's an example of great jobs being created by automation, but the public sector didn't get us there first. The private sector had to go to the public sector and say, these are their needs. And so I think that's what we're going to see in the short term. I would love to see the public sector figure out how to get those lessons taught earlier in life, just as when I was in high school, we had mechanical drawing and drafting. I don't think they're teaching those anymore in the public school system.
Natan, you want to speak to the same question, please?
Yeah, I mean, we're seeing the same trends, and kind of just to build on that point and kind of give more numbers to what you mentioned before. I think by 2025, it's roughly between 5 to 6 million people who are going to be missing in the U.S. workforce. And we're in an era where programming is now the new literacy, right? So when we come, when I meet a lot of whether it's head of a factory or a CIO, that their job is like to do digital transformation for a production line, and they go, well, we need smart manufacturing. And you go like, well, what do you mean? And they're like, yeah, well, we don't know exactly, but it's got to be smart, right? And what they really mean is that they want their people to be able to respond to change, okay? And that requires understanding of data and how would you digest the data, or even before that, how would you collect the data? Now, when you come to think about it, we have this massive, global, super fast operating system called the internet. And you can take almost any kid today, and by the way, it relates also to Internet of Things, though I do have a beef with that subject, because there's really no Internet of Things, much like there's no Internet of Humans, just one internet. But my point is that any kid can pick up an Arduino type microprocessor, and that's like where the PLC has evolved to, and stick it on a machine, and then fast forward into the production line, and start building something that would collect data and do something with it. The problem is that that doesn't scale. And when you think about where all that human knowledge that went into like really quickly making websites and pushing in apps to these phones and that kind of stuff, that had kind of skipped the shop floor. And I think it's making a really serious U-turn going 120 on the highway. And there's a very simple reason for that, is because it's, without that type of infrastructure, manufacturing cannot really change. And the irony is that when you think about automation, and I'm sure you can help me amplify this point, and in manufacturing, these are organizations that know how to spend CapEx. So they know how to build machines and put lines and bolt them down and like run a lot of tests. And the production line is a product. Like you never stop working on it, because one day you have an engineering change, another day some people are sick, and you have to like be very dynamic running it so you are competitive and like supplying products. Well, how do you respond to change without this thing called software? So the point I'm trying to make is that the future is really about manufacturing that is driven truly by software. And to do that, you need people. You need the process engineer of the future. They need to be people who have the ability to program a production line. But a production line is not just a little widget behind a screen. It's a physical environment where you have tools and robots, and they all need to be working in wonderful harmony and concert to produce the thing. Well, you need new development tools and new debuggers and new profilers, right? And there should be a whole stack for that. And I think at Tulip we're focused on one part of the stack. I'm sure the autonomous robots is another part of the stack. And for people to exist in this reality without having a PhD in computer science is the challenge. And I think the only way to do it is really almost in situ. So like train people in the real production lines. And I'm very excited about how that might look like in the very near future.
Well, I'd like to know your view on people who are not in situ. They don't have jobs. They're not in the workforce, and there are all these technologies that are very future-facing and increasingly accessible. You mentioned Arduino earlier, and for those who don't know, Arduinos are these chips that you can actually program to do various things, to take inputs from sensors and then to react to those using actuators of one kind or another. So for example, you can take an image from a camera and then respond by maybe closing a door or opening a door, depending on what the image is and so on. And so access to these, one of the definitions of how this is happening is in the maker world. Yep. So there's people who don't have a background in engineering who are being taught how to interact with technology at a high level. So they're not going deep, but they're theoretically, supposedly able to get enough knowledge to do very useful things using the technology and maybe even invent new products and so on. The Fab Lab network is about that. Do you think this is real in the sense that...
Yeah, that's super real. And like a lot of the customers we're meeting and partners we're meeting there, it's really about how you turn the process engineer into a hacker, a maker. you know, there's something super satisfying when you're hacking, when you're seeing like quick iteration. And software is, of course, specifically because like you write a little bit of code and you compile and boom, something happens. And when you're in the physical world, you're dealing with hardware, it's just obviously cycles are longer, but it's still very satisfying for those individuals to feel the empowerment in this rapid cycle, like to come into a line and say like, hey, you know, I don't think that this torque gun is programmed well. I'm going to go and change some stuff, and then suddenly your quality drops and your first pass yield comes up, and you know, if they have the tools to show this to the people they work with, their team and their management, that's pretty amazing. And like that, those are the cycles of data I'm talking about when you really want to change something, you know, with no feedback loop. How can you actually achieve that? I think that in standard IT land, or where we measure how we do anything online today, we take that for granted, and that is something that, you know, would change how we do things that are more in between digital and physical more and more.
So, I mean, leading into, I mean, building on this point about the makers and so on, I'm incredibly fascinated by Shenzhen and the little that I know about it in terms of the kinds of things that happen there, how quick it is that you can go from an idea to a product, and who is actually doing all of this. Is there much of a maker movement in Shenzhen? Are there people who don't necessarily have engineering backgrounds creating new products and able to get them into the marketplace really quickly? Maybe Danny, you can speak to this and share with us your
I think you like the Shenzhen is very correct, because everyone in China will like Shenzhen because the speed of Shenzhen and also the innovation of the Shenzhen. And the Shenzhen, the reason why they can transfer the idea to the manufacturing and also a lot of the modern manufacturing, the reason because it can attract a lot of talent of all over the country. And the most important is Shenzhen and by now I think the Shenzhen, even by the university, just very limited top university in Shenzhen. So the people who produce this kind of the technology person and workers is from the society. So that's the reason we're talking about the public and the society need working together. And also very important is actually, it's just like a system, just not one company. There are a lot of companies that can connect with each other. Some produce like a drone, some produce like a micro chips, and some produce other things, but they have like a connection. And also they're training the workers, because we have the clients here, a lot of leading local Chinese clients here. In their manufacturing, they have not always just like high-tech peoples. For example, like a Huawei, they have more than a couple thousands people in the factory, but they also need a low and entry-level workers need the training. We also participate in to help them to get this kind of the workers. So that's the reason I think they just cut the whole project, it's a large project, into the some factors, which is a low skill. One is like a good university graduates, which has the right big data or the digital skills from all of the country. And the number three is a practical for the business line, from the upstream to the low stream. There are a lot of talent can shift across. And also most important thing is plus the financial sector, because venture capital and PE is very active in Shenzhen as well, and also close to Hong Kong. So that's like a combination. And this is actually Shenzhen become the model of a lot of China second-tier cities and third-tier cities willing to do this like agenda, which we call the China Manufacturing 2025. Which the China wants to improve from the low manufacturing to the high-end manufacturing, and also put the China workforce from the quantity to the quality. So it will be the very modern cities for the future.
So in your view, what's happening in Shenzhen in terms of new companies being formed all the time, those people who are coming up with innovation, you say are not necessarily university graduates. Where do they get their training? How is there a system there, an informal system, or is there some government support that directs somehow the way it happens?
Shenzhen is a very unique city. Actually, very beginning, they come from the government, which was quite small, and it's very famous for freedom. So set freedom of the companies and the individuals. So they welcome the people from all of the China into the Shenzhen. So the population, over 60% of the population, not the local Shenzhenese. So they come from all of the world. And how to train this kind of workers a skill, which is majority is the private sectors actually.
Okay.
The public sectors, they have the directions, they have a lot of, they help them to get this kind of talent, but majority spending is individual companies and the private sectors. So it's a very good example for China, yeah.
So I want to shift a little bit and get some of the audience to come in now. And as well, any of the panelists, if you want to jump in on a point or make a point, just feel free. Is anybody in the audience ready to ask a question to any one of us? Yes, so lady over there. Gentleman, I'm sorry.
Hi guys. So my question, my name is Alok and I'm part of the Global Shapers community and 3D printing expert network. And so specifically my day job is with a 3D bioprinting company where we're automating and bringing in the convergence of engineering, biotech, machine learning to mass produce skin tissues which will be used for as alternatives to animal testing. But my question to the panel today is more on the lines of the recent report that WEF released on the future of jobs, came out yesterday. So there is mention of about 75 million jobs which will be replaced by robots by 2025. There's also optimism in the report about 133 million new jobs being created. So my question is around the fact that today, as we understand that there's 133 million jobs being created, is the education system in place to create the right kind of jobs? Is the apprenticeship system the way to go to create specific skill sets and specific jobs, or is the 4-year degree still have value? Thank you.
Professor, you want to take that?
Well, I think the answer so far from the panel is no, all right, when catching up. I think one specific point is that, like in Hong Kong and China, vocational schools, vocational education has been kind of decimated in the last century. The tech schools got upgraded, quote, upgraded to comprehensive universities because people think that's more respectable. And the answer is no, right? And I think we need to bring back the kind of vocational training at a more advanced level and make it exciting and interesting. So not everybody have to take those very tough exams, to get into the so-called comprehensive universities, and people kill themselves for failure to get into those universities. So people need to understand there are diverse career tracks. There are all these opportunities out there, and then the system has to change. And I think we talk about skilling, reskilling. I think a lot of training, quote, needs to start at the top, at the university administrators, at the public policy makers. They need to understand. They need to learn about all these possibilities that's going on and be bold enough and have the guts to implement the changes. And people understand. People not that they, but you need to do it, all right? And to face the challenges.
Yeah, you're itching to get in.
I could just jump in. I completely agree. I think that's one of the big, a real challenge we have here is over the last 20 years, the university degree became this huge thing. And so you have people going into debt, stressing themselves out, getting these advanced degrees. And we've created a major gap in capabilities, which is the apprenticeship, the journeyman, the people who graduate from a high school and are very mechanically gifted that can go in and run, learn how to do CAD/CAM, right? To run a 3D printer, to run a 5-axis CNC, you need someone who can set it up and program it. We don't talk about that. Those people are machinists. If anybody's tried to hire a machinist recently, they're usually 78, 80 years old, and you're going to pay a lot for them because it's a skill that we have just let go by the wayside. And so I couldn't agree more. I think that's something that the public sector has to get on board with immediately is the apprenticeship, the journeyman, and how do we fill this gap? Because we've produced a lot of people with university degrees, but we haven't produced the skills we need for the manufacturing economy we're living in today.
Just to add one more quick comment, because I think my colleagues here covered the main points. When we talked about the skill gap, and sometimes this goes along with what we call silver tsunami in the U.S. This is like the boomers exiting. But there's another very simple phenomenon. When you have human labor, they're already in the manufacturing workforce, but because of the level of automation, and the level of IT in those, down in the shop floor. They might be spending up to a third of their time chasing data and doing stuff that humans are not really good at, which is things like reporting. And the reason we're not very good is obvious because we're subjective and we have opinions, and that's not really good for this thing called data-driven decision. Can you imagine like people chasing down Google reports and like having an opinion on it? No, you're just looking at Google Analytics and you make a decision. What happens when you introduce more robotics and more systems like the stuff we do and clouds come in and things like that is that those people are going to have more time. And when they have more time, there's no void. Like it's going to be sucked into the gap and be used like to fill in all these jobs that we're talking about. So that's one point. And then the other point, we mentioned our friend and colleague Rodney Brooks, whom I used to work with, is a very famous roboticist. And the thing he used to tell me all the time is that, with respect to the same void, is that when you let the robots do what they're good at, human ingenuity kicks in. So they will just take, we should not worry about the robots. It's totally fine. Robotics is like a disappearing, set of, think about your washing machine. Like, does anybody want to go back to a world with no washing machine? That used to be a very fancy robot. We just don't call it that way anymore. So I think we should keep working on getting technology into manufacturing and let our ingenuity take its course.
So it seems the panel is really quite optimistic about the future where automation is concerned, that there will still be jobs. I'd like, yes, a gentleman there with the silver hair.
Yeah, I'm Carsten Otto from Germany, from the Kaizen Institute. I have a question in a similar direction. Yeah, the workforce from tomorrow are young people now. My students from the university ask me a lot of time when we finish our study and we have a diploma certificate, and then we come from the university, in the reality, we must start by zero. Yeah. Based on your experience, what can I recommend such young peoples? What can they learn additional to the normal study and education? I learned from you, madam, languages and so on. But what for other possibilities, please?
I think I need to throw the question back to you. What do you mean by normal education that students have received from your institution? We've got to start from there, right? What have they learned? What do they have to bring to the table when they graduate? Be it technical, be it the language, be it whatever, right?
They come from university, Heidelberg, old university, yeah. They learn medicine, technique, engineering, whatever you want. And then they come in the market in the real life. Oh my goodness. Yeah. So it means
Please bring the microphone to the gentleman.
I'll defer to my industry colleagues.
MIT has a very simple, quick answer to that. You need to teach them how to never stop learning.
Yes.
That's it. Yeah, they need to, yeah.
Absolutely.
Well put,
exactly
well put. I have a question over here in the front. Is there a mic?
I'm Elaine Zhou from US. I work for a company using...
A little bit louder, please.
I'm Elaine Zhou from US. Work for a startup in the AI business. I have a question to you, Mr. Vause.
Yes.
You mentioned one of the reasons in the Google Go example, humans' advantage is really ability to adapt.
Yes.
Right? So the question is, in the AI world, it's only a matter of time for machine to be retrained. So the time is going to shorter and shorter. And the other thing is you have the environment have constant uncertainty, right, which translates to disasters a lot of the time, instabilities, right? But what we're trying to do is create a world that is peaceful, stable, predictable. So my question to you is, how can humans continue to be advanced, be ahead of the curve with the machines?
This might be a little controversial. I think we're way, way behind in reality on AI and machine learning than what the popular conception is. And the example I like to use the Go example, but the other one is, and I'm not just picking on Google today, but they've done a lot of really good work about adaptability in robotics. And so Google has this big cannon that shoots money out of it called search engine, and so they can fund this research. But they took, I want to believe it was 16 robots over a 6-month period, 800,000 manipulations to teach those robots how to pick up an item set of 50 items. So arguably one of the best compute companies in the world, unlimited resources. They needed 6 months, 800,000 manipulations to learn 50 items. Amazon has 22 million in inventory on any given day, and what they have in inventory this time of the year versus what they have in inventory in June versus what they have inventory in December are very different. So it's not teach 22 million items, it's teach hundreds of millions of items. And so what I see is, yes, I know compute is getting cheaper. Yes, I know the cloud is changing it. But I still think today, as Natan said, the best compute engine out there is the human being, and it's going to be many, many years before artificial intelligence, I think, will displace a human. I think artificial intelligence will make humans infinitely better. They'll increase bandwidth. They'll let the humans focus on higher value items. But my opinion today is I think it's going to be many, many years before the human is taken out of the process.
That's what they said about an AI system beating a Go expert. And it happened a lot shorter time. And I guess the point she's making is that the cycle time that the AI system takes to learn is really the only limitation. I remember reading recently that there was a debate between an AI system and a human being where the AI system won. So, you know, going through tons and tons of articles and so on to get their information.
It really gets to the constrained problem. And I think the more you constrain the problem, the better the AI is. When you get into an unconstrained problem, and I like to use the example of the traffic sign. So a brand new stop sign is bright red, brilliant white. After a couple years, it's an orange and a gray. To us, that's the same sign. To an AI, you have to plan for an infinite variation of colors and the infinite matching of just 2 simple colors to be able to recognize that sign. I mean, that's the reality of it today. I'm not saying we won't get there, but what I always think about is I think about humans as the quality assurance for AI. And that's where we will continue to provide value, whether it's robotics, machine learning, and AI is in the end, the human is better because of the AI complement, the way I see it.
Okay. Yes, gentleman over there with the beard. The mic to him, please. Yes.
Thank you. My name is Rafat. I'm from the Pathways for Prosperity Commission, which is at the University of Oxford, looking at how technology is impacting developing countries specifically, and how all these changes are going to change inclusive growth and development in these countries. And I was just struck, a lot of the conversation focused mostly on the US, at least on the industrial side, and how these automation and robotics are necessary because you have what you call the silver tsunami and all that. And I wonder if what you have to say about in developing countries where it's opposite way around. I come from Yemen. I was Minister of Youth in Yemen, and we had 4.5 million young people looking for jobs and not enough jobs there. So if we're automating all this, and if production by robotics are going to be much cheaper than the cheap labor that we have in developing countries, where do you see that impact on the developing country side?
So we do work in what's typically is defined as developing countries, like Brazil, for example, or very closely related, which I think is just economic factor, right? Lower labor wages countries, right? Where traditionally, like the past 10, 15 years or so, a lot of labor moved from Western economies to lower labor rate economies, you know, mainly just because of the cost issue, right? This is really a sort of a labor arbitrage kind of question because specifically as it refers to manufacturing, because manufacturing with its complexity, it's really reduced to a supply chain problem, right? So where can you manufacture something that it makes sense to like take over all the complexity, ship it over so you can supply it to the customer? Where you're doing stuff that is mass produced, it's much easier. When you do stuff that is customized, it's harder. So when it comes to your question, this is at least what I'm seeing is you're seeing those low labor economies trying to take, so when you put like that type of, and I'm being very high level here, right? But when you take like the average Western worker, they might be making more money, but they're capable of doing more complex tasks over this sort of the same period of time as opposed to other countries. That's why where you visit sort of those factories, you see lines of lots of people. And obviously in those countries like China and India, there's just a lot more availability of labor. So you see those huge production lines and people are doing 1 or 2 discrete operations per station. As opposed to you can see the same sort of, not this exactly the same line, but fundamentally similar set of discrete operation done on a couple benches just with 2 people. They might be getting paid more, but are able to produce something that is more complex. So what's happening is that in the Western economies, you have less and less of those people. And in the lower labor rate economies, you're seeing as their rate increases, they want to make their operators seem like more the people on the West. So there's only one way to do it, and this is not, you know, if you're not going to introduce technology into that environment in those economies, you're not going to get there. So you have to make those lines in China that have 200 people in them, not only produce the massive amount of product they need to push out, but they need to do it, you know, with like less people that are more sophisticated. And you can't do it without technology, in my opinion.
If I could just make one comment, because we were talking about this earlier, is think about what you're producing, right? When we think manufacturing, a lot of times we think about we're making things and shipping things. But we were just talking about initiatives to train software developers in Kenya who were then outsourcing their work into Europe and the United States. I can tell you machine vision engineers in the United States are very expensive and difficult to hire. So I know a lot of companies that are using machine vision engineers in the Ukraine. So they're very good jobs in the Ukraine, driven by the skill gap in the Western economies. And so I'm seeing a lot of that happen now where it's production, it's just they're producing maybe software code or other things that they're exporting versus traditional hard goods.
Mm-hmm. Maybe comment here.
Those are global examples. I think we need to think global, work global, but also regional. Maybe you can find a hub, your regional hub, where kind of leveraging and sharing can take place. Like back to Shenzhen. Shenzhen does not just attract graduates from around China, but also from around the world. From the best universities, they go there. And then in Hong Kong is a financial hub. Manufacturing has moved inland for a long time, but now is the second iteration about upgrading it and also moving more manufacturing inland at a higher level, right? Into the villages, into the rural areas, and to have the cost benefit and helping to upgrade the skill. So there's a regional activities going on, and that would be helpful because no longer the geographies are becoming less important.
And building on that for you, Danny, when Shenzhen, the land is becoming more expensive, workers have to live farther away than they ever have to get to work. It is difficult, and the labor costs are going up. What do you think the chances are that a Shenzhen-like model can be exported to countries like Yemen or Kenya, where there's also like growing populations and therefore markets and so on?
That's just a good example, which we happen in the Guangzhou as well. Actually, a lot of China cities, because the labor cost and the land cost improve, so they attract the global-wise the talent to come to the China. And also this kind of the private sector trainings also happen. Actually, just the professor have the example like language learning, which is not only the China. Used to, we have a lot of leverage with the Filipinos, which can speak the English and also lower cost in the Asia area. So not only the language skills, but also the manufacturing related laborers in the Cambodia, in the Myanmar, in the other areas. This is already built, I think that China has agenda, the one belt, one road. So I think a lot of things which will be connected to how to mitigate the improvement of the revolution of the skills and also revolution of the industries. I think that's the connections here.
Great. Yeah. So we only have a couple of minutes left, so I want to give the panel an opportunity to wind up and just say the last few words and really just relate it to what you think the future holds in terms of manufacturing and the capacity of our current systems anywhere in the world to really keep up with the pace of technology and not to always have to play catch up. Please, starting with you, Natan.
Yeah, I think we're going to see a new class of information worker emerge. Much like we spent the past 20 years looking at the IT knowledge worker class emerge, and we know what to expect of them. That's where I'm most excited to see a future workforce that is built on what I think Mimi Ito coined as like mobile natives, people who grew up with these devices, and this is the interface for their world, right? They will bring it into manufacturing, and we will all see what this brings on as they talk to new systems, as they study more and more diverse sets of manufacturing techniques. And just to give one anecdote where I think the old and the new will coexist. So mentioned here was craft, and I think the gentleman from Yemen, maybe an idea for him is to think about we have all this great human knowledge and how we used to make things, with hands and with the local resources. So we're seeing like companies who are, you would define them in the craft area, that they have like literally hundreds of years of knowledge of how to make certain objects, and it's disappearing unless they introduce some component of technology while preserving the craft. And those two things coexist, and that that's where I see that new class of process engineers, knowledge workers emerge. So sadly, that's going to have to be the last word because we're out of time. Sorry. But that was a very good summary, I think, of what perhaps all of us think is the future. So thanks very much to everybody. Hopefully you get a chance to interact with anybody if you had a question. Thank you.